Welcome to today's webinar. While it is entitled API Security Insights for the Connected Vehicle Ecosystem, we believe that a lot of the learnings shared by our presenters today apply in equal measures across all industries, where APIs play a fundamental role at the heart of innovation and service delivery. So if you're not directly involved in the automotive space, please don't tune out. Many of the same issues will exist in your sector too. The first part of today's session is designed as a discussion between our two presenters with a lot of constant to and fro. There will be live Q&A with Darren at the end. So hopefully you'll find it entertaining. Our presenters today should be familiar to some of you, if not all of you. Anthony heads product marketing here at 42Crunch and is also editor of our API Security.io newsletter. Darren Shelcusky, our other speaker, oversaw the cybersecurity program for the connected car at Ford and is a veteran of the automotive industry, where he has led software-based initiatives in manufacturing, product development, product testing, in-vehicle connected vehicles, and cybersecurity. So, what he doesn't know isn't really not worth talking about. So I will hand over to Anthony now.
Okay, thanks you. Hi, Darren. Thanks for joining. It's a pleasure to speak with you.
Thank you for having me today.
So we're going to talk about API security in the automotive industry and about implementing a DevSecOps approach for developing and protecting APIs. Now, you recently wrote a white paper on the subject called End-to-End API Security for the Software-Defined Vehicle. It's a great read. I'd highly recommend it. Could you start maybe by giving us a brief overview of your background in the automotive industry? So what your areas of expertise are, and then your past experience with maybe DevSecOps and API security.
I'm a youngster in the industry, so actually this year is my 44th year in the industry. So in that time in the industry, I've had a very full career, and what I've done, I've led software-based initiatives in manufacturing, product development, product testing, in vehicle software, connected vehicles, and toward the latter part of my career, cybersecurity. I retired from Ford, after a 35-year career with Ford, in the position of manager vehicle and product cybersecurity for that. So, like I said, I finished my career in cybersecurity. Areas of expertise, what I would consider myself that I know. Again, obviously cybersecurity for connected vehicle ecosystem, vehicle tech stack, clients, cloud, APIs, what we call in the industry is a VSOC, or in a traditional IT world, you would consider it a SOC. Cyber physical systems. So basically things that move, things that change, things that be able to do it. Like I say, I failed at retiring, so I immediately became a consultant for the automotive industry, and I've been doing that now for the last several years. It's been a great ride so far, and I'm still enjoying it. As far as the DevSecOps, again, part of my career has been software development, whether it's client, I've done in-vehicle embedded systems, real-time systems, cloud systems, so all those things that you would do specifically, for those types of systems, build validation, automation and whatnot. I mean, it's stuff that I had to live, especially growing up in the safety critical world. Those are things that aren't a nice thing to do. It's the things that, if you take your job serious, are things that you do. So while DevSecOps may be new to the IT world, for people who've been doing safety critical systems, it's been something that's been around for a long, long time.
Okay, well, for a youngster, it sounds like you've been very busy. You're just the man for us to talk to on this topic. Well, look, there's a lot going on in the automotive industry. It's really exciting. There's so many different features and innovations in vehicles nowadays. There's things like adaptive driving, all the safety features, fleet management. So in the white paper that you wrote, you talk about the connected vehicle ecosystem. Can you sort of paint a picture of what that ecosystem consists of? And then also, where do APIs fit into the picture?
Sure. When we came up with the term and the idea of the connected ecosystem, and specifically looking at a system, a software, cybersecurity perspective, came up with the definition. So, and this is the definition I came up when it was adopted. At its core, the connected ecosystem honestly consists of anything that can read or change the state of a vehicle. So I have a product, a vehicle. If I can read from it, if I can change the state of it, basically turn it on, turn it off, update software, those become relevant and are part of the connected ecosystem. And from a regulatory perspective too, those fall under the regulatory perspective well for legislation such as UNECE and whatnot. So here's how I like to think of the connected ecosystem. I think that people can understand. Take our body. Our body has a central nervous system. And this is kind of where the APIs come into play. What does our central nervous system does? It delivers messages. Hey, I'm feeling hot. I'm feeling cold, pain, move my arm, whatever the case may be. And again, the central nervous system is really the primary center of the body responsible for processing, transmitting information. It coordinates our voluntary and involuntary responses, the things that we do every day. Well, think about it in APIs. It's the same way. They become the central control system for the connected ecosystem. Whether it's command to say, start my vehicle, ask the vehicle during a health report, update the software, whatever. These commands, these nerve messages are flying through this connected ecosystem. And behind it, at the end of the day, APIs are basically the messages flying between, whether it's between a mobile app and a vehicle, whether between a vehicle and a back end, whether it's between my Alexa telling it to start my vehicle, whatever the case may be. When you look at it at the end of the day, that connected ecosystem, the APIs are those messages flying between the various nodes of the body. In this case, the body being the connected ecosystem. If that makes sense, I mean, to be able to do that. That's how I've always envisioned it, and I think it's something that people can understand.
Yeah, so in addition to the standards, Darren, there's also very strict regulations that impact all the members of that automotive ecosystem. Can you describe some of those regulations and their impact on the API development?
Sure. I'll probably hit the biggest one, probably most people are familiar with. It's from the R155 and R156 from the UN. So basically, what at the end of the day, what that does is it mandates to the OEM, in order to sell a vehicle in a market, they have to actually have an independent outside party, governmental agency or the governmental body or their agent, validate their vehicle for product cybersecurity. So that's R155. In addition, they look at the cybersecurity management system. Do you actually, as an OEM, have the processes in place that are repeatable, sustainable to do it? So there's also, they call the cybersecurity management system. And the stakes are high. I highlighted out in the white paper, there are certain OEMs that stopped selling vehicles in the market because they weren't going to be able to pass cybersecurity regulations. So think about that for a moment. They had a product in the market people wanted. They've been selling it for years. All of a sudden, they can't sell it anymore. It's a big deal. The stakes are high if you get it wrong to a company. So if you're in a country or an area that, for example, that has, if you're taking your vehicle ever in for emissions test, you'll go up to the emissions center, they'll test your vehicle and say, you pass or fail on the emissions test, you can drive your vehicle, you can't. Well, think about that now for a company. It's like they're going to look at your vehicle and you either pass or fail the cybersecurity test. And if it fails the cybersecurity test, it's like, well, you got to do something about it because you can't sell it. So imagine now all of a sudden you had launch dates planned and everything else like that and marketing literature, and it's going to take you 3 months, 6 months, whatever, to address or whatever they take to be able to do it. That's pretty significant to a company because a vehicle launch is a big deal. It's not something that's small. It's who we are and what we do. We manufacture, sell, market, service, products. So imagine that if you're a software company now that says you're at 42 Crunch, now you got to get Darren security thing to review your software to make sure what you did is, up to speed. It's quite a different mindset for people to be able to do that. Now, regulations, I mean, the industry's had them for a while. We've had crash tests and other things in order to sell vehicles, but this is for software. It's a first. Cybersecurity, it's a first. And the ecosystem is a first. Remember, I talked about the ecosystem is anything that can remotely read or change the state of the vehicle. So imagine now that Alexa, start my vehicle, is now part of your ecosystem. And it could be something that could, trip you up on selling a vehicle if you didn't do it right. So imagine all those different things. So maybe not even be things that you own. Okay, as an OEM, we don't own Alexa. We may write a skill in it, but we don't own Alexa or the things like that or whatever. If I put weather into the vehicle in the nice center console, it's the weather where I'm going. Well, automotive companies don't do weather. We'll license APIs from weatherrus.com, be able to show that. So imagine if they don't do it right or to be able to do it, whatnot. So it's not only you, it's the stuff you write, it's the supplier ecosystem, it's the third party, it's the frameworks, it's all those other things now that come into play that you have to show and demonstrate that you're on top of all those things as a company, and making sure that if Alexa has a problem and there's a patch or whatever that has to get out, you're doing the right stuff to make sure that Alexa now doesn't become a problem for your vehicle. So it's me. And by the way, you have to do that for the life of the vehicle, which is on average about 15, 16 years. So imagine doing something like that for a 15-year-old vehicle.
Yeah, it really underscores, it really underscores how API security is, it's not a nice to have. It's an absolutely critical part of the automotive ecosystem. And of course, then with more connected systems, you get an expanded attack surface for potential cyber attacks. It was interesting. I was reading an article in a security magazine just earlier today, and it was titled "The Future of Automotive Cybersecurity: Why Learning Car Hacking is Essential." So, there seems to be a particular focus nowadays on hacking vehicles, both by, ethical researchers, ethical hackers, but also by, malicious hackers. I think a great example of that, you reference a report from 2023. I think it was titled "Web Hackers versus the Automotive Industry." It was a fairly provocative title. It was published by a team of researchers, including Sam Curry, whose his work would be well known in industry. Can you explain the relevance of that paper to automotive security, and especially in relation to API security?
Sure. So first, I want to say to the researchers, I take my hats off to them because I think they did a really service for the industry.
That's it.
When I talk to most people, or people find out I'm in automotive cybersecurity, they all go back to the 2015 GPAC. Well, and that was so bad, and they could remotely control it. And some of the inconvenient truth about that, while it was important and it kind of opened the era of automotive cybersecurity, it took 3 years of research. It took to impact a single vehicle and a single manufacturer. So while it was important, and I don't downgrade the work that the team did, compare that to what Sam Curry and the team did. 3 months, they impacted 19 different OEMs, where they could do things such as, remote command and control into the back end systems, into dealer hubs. I mean, into source code, you name it, be able to do that. And what did they highlight? I've talked about this before. Picture a turtle. Okay, a turtle has a hard shell, but a soft underbelly. And if you turn the turtle over, you can attack through the underbelly. So I call out that basically what they showed is that the APIs are the soft underbelly of the automotive ecosystem. So we may have this hard shell on the outside. The reality is what they exposed was different things that related to APIs that weren't being done well. And people in the industry, if you're familiar with the term OWASP, and there's a top 10 OWASP for APIs. I joke with people on that, and I've done this in presentations. It's almost like if I had a bingo card. I could go down each of the manufacturers and play OWASP API bingo and put on, here's Ebola attack, here's this attack, here's this attack. So what they did was not novel in any stretch. It's stuff that we as an industry and the API already know. It was really about the implementation or lack thereof on their products, not addressing known vulnerabilities against, APIs. So at the heart of it, that's what it was. And that's why I said I think it was a great wake-up call for the industry, because a lot of these APIs were hooked to things, I call them cyber physical, where I could start a vehicle. I could, do things, that I may not want someone else to be able to do, to my vehicle.
The hackers, they were looking for the weakest point in the ecosystem. So it's not that they're just going directly to the vehicle to look for vulnerabilities. If they can find a vulnerability anywhere in that ecosystem, it's a potentially huge impact, both in terms of hacking the car itself or the vehicle itself, but also, as you say, in terms of regulation.
Right. And if you look at the Sam Curry, some of this stuff they're attacks, I won't name names or anything, but wasn't the automotive systems, it was a supplier system. But the supplier system was hacked, and it ultimately ended up impacting the vehicle. So that's why I said these third parties and all come into play. And you really have to have that systemic viewpoint of what actually is changing the state of the vehicle or reading from that vehicle and understanding that.
Such an important point.
You
Yeah,
know,
I found it was really interesting just to see a sort of a first-hand account of the tactics that are used by teams sort of to penetrate those automotive APIs using fairly simple techniques like, what will happen if we send the API an unusual, unexpected parameter value, or what happens if we change up the URL path? How will the API respond? And more often than not, from that report, you could see the automotive companies, the APIs behaved very unpredictably. Right? Sometimes, as you say, the authorization was bypassed or the customer data was leaked. So it just seemed that a lot of the APIs that were hacked, they weren't designed or coded very well, or not, at least not designed or coded for security. So they probably worked very well under like normal conditions. But then as soon as somebody started to send unusual input, the APIs behaved very unpredictably. And that's dangerous.
absolutely, absolutely. Let me share an anecdote with you. When I did safety critical software, when a person joined my team, I had them read a case study, and the case study was called "We Did Nothing Wrong." Basically, what it was is about a software malfunction in a radiotherapy machine that ultimately led to radiation overdoses for 28 patients and 18 deaths. And it was a very simple flaw. The software was designed to handle up to 4 protective shields, and the operator used 5, and it allowed to input 5 into the system, and the result, it made incorrect calculations in the radiation. And it started asking the question about software engineers. Okay, are you liable for manslaughter? Are you liable for criminal intent because you didn't do these types of things? No. While in this case it didn't, there was lawsuits and whatnot, but it started the discussion about what is my role as a software engineer to do things right. And that's where I think take that now to the APIs. Okay, APIs should be defined through a contract. In APIs, it's very simple. As I would say, if you give me this information, I will give you this stuff back. It's a request and a response. So it's a contract between a producer. I produce this service for you, and a consumer. I want to consume this service, be able to do it. It's spelled out in the contract. Well, we're in commercial companies. What happens if you write a poor contract? You're not going to be in business long, because contracts are meant to be enforced. That if I give you a product or a service, whatever, I will give you money or whatever the case may be. Well, if that's not clearly defined, that's where companies get into trouble and get out of business. APIs are no different than that. Like you said, what did Sam Curry do? Nothing fancy. It's like, well, okay, you said, I'm going to accept a VIN. The VIN is 18 characters. What happens if I put in a 30 character VIN or something that doesn't look like a VIN? What's it going to do? Or what happens if, I'm Darren, but I put in the VIN for Joe? Should I be able to look at Joe's stuff? All they did was basically manipulate the input for the most part.
That's
Nothing
right.
ultra sophisticated, but at the end of the day, the contract were either one of two things. They were written poorly, or the actual implementation of that contract in the code basically ignored what the contract said and didn't enforce the contract. So in all cases, it was either one of those two things is what was highlighted by Sam Curry. It's basic blocking and tackling not being done. And as I showed you with the radiotherapy machine where people died, unpredictable behavior can be dangerous or deadly, depending on the nature of what's behind that API. If it's something that's cyber physical, oh, absolutely.
Yeah, it's such a critical and yet basic part of API security. And it's one of the ways that we help teams with this at 42 Crunch is to use that open API definition to define very precisely how the API is intended to be used and secured at runtime. And so that helps teams to build, very predictable APIs that aren't vulnerable to those types of attacks that we've seen against automotive APIs. And I love that analogy you give of sort of the legal contract and how that applies. So how do you, with that concept of a contract, how do you leverage that for API security throughout the API development lifecycle?
Sure. So in the automotive, I said we view, at least me, I view, maybe not the whole industry, but I view through 3 lenses. There's an idea of as designed, as built, and as consumed. So take the Open API document. That is design, but I'll go even one step before that. It's a design intent. I'm intending to create an API that will accept these inputs and return these outputs. The actual design itself, or as built, is the code. The code implements the design. And then finally, the last part we look at it, is it consumed? How is it being consumed? Everyone on this call hopefully has a vehicle of some kind. So like you have a Ford, F-Series vehicle. Well, it's designed to hold so much cargo, so much weight and whatnot. Well, what happens if I put more weight in it than you're supposed to do? How is the system going to handle? So that's an example to be able to do that. So we as an industry look at how are things actually consumed, because I intended this to be used in one way. Are people using it in another way, or in a way that doesn't matter? And that's where 42 Crunch lines up right into that. The Open API contract is your design, you design intent. The conform and scan is validating that it was actually built according to design. And then the firewall shows, are we using it in a manner that we expected it to be used in? Or are people using it differently, which may be a good thing, it may be a bad thing, but it's understanding that dynamics of consuming an API. So it fell right in, to the way we in the industry view our products, physical products being vehicles. A software product is really no different.
Yeah, there's an interesting parallel there. These practices that we're talking about then for API security, like using the Open API contract to link that as designed, as built, as consumed, it seems to be very similar practices actually that are mandated for functional safety, which I guess it kind of makes sense, because in both cases for safety and security, the goal ultimately is to produce predictable software that, for software that does exactly what it's supposed to do and then nothing else. Is that a similarity you see with those practices, both for functional safety and then developing secure APIs?
Absolutely, and I've said it multiple times, undefined behavior is dangerous, whether it's in an API, whether it's in safety or whatnot. So again, I give an example on putting a window up. Is that a safety critical operation? Yes, it is. What if it's remotely doing it and you have a child sticking their head out the window, or a pet or whatnot? What would happen? Again,
conditions matter.
Exactly. Conditions matter. So things, be able to look at that. That's the way we in the industry look at those types of things, especially when it's being done remotely. Starting a vehicle, remote start, it's a great thing. It's cold out today. It's 4 degrees below 0 Fahrenheit. Hitting it to start my car to warm it up to get out is a wonderful thing. However, until it's not a wonderful thing. What if that's now in a confined space? Carbon monoxide poisoning is a real thing, unfortunately. Well, the auto industry says, I'm only going to allow you to run it for 15 minutes. Well, if I'm a malicious guy, what if I can keep calling the API and a script continuously that it never shuts off? So what happens now all of a sudden to be able to do that? So in the industry, we look at these use cases as well as I call them misuse cases. So where we ask the question, what happens when this occurs? And if I got a nickel for every time an engineer looked at me, it's like, why would anyone do that? And I'd say, no, you're missing the whole point. What happens when someone does that? And the answer is, I don't know. You have an undefined behavior, which in a safety critical or an API gets me very scared, because you have no clue on how your system is going to operate when this condition occurs. And at the end of the day, whether it's safety critical software, which obviously the stakes are higher, functional safety, or it's Sam Curry software where maybe I'm just doing something where it's not as critical, it's still a problem.
Yeah. So just to recap then and what we've covered so far, so we can remove API vulnerabilities using better design practices, and then we can leverage the Open API contract to ensure that we're building and deploying APIs that, as you say, are more predictable and then more secure. So then when it comes to actually implementing a DevSecOps initiative or program, so you have experience implementing DevSecOps at a major automotive company. So what do you see as the key challenges when you're trying to, let's say, integrate API security practices into a DevSecOps pipeline?
Yeah, the challenge is security, cybersecurity in most companies has authority and power. So I guess I'll go to coin the phrase from the Spider-Man movie, with great power comes great responsibility. So what do I mean by that? I've been a software developer, an engineer, developed software, so I know what that life is. I've lived that life. I'd be able to do it. Human nature hasn't changed. We as creatures are going to take the path of least resistance and try to do the things that's the easiest. So the challenge in any company, large company no different, is what we do is we make the right thing the easiest thing to do. Because if it's easier for me to do the right thing, I'm not going to go around and try to get around security or do what I call cybersecurity theater to give the illusion that I did this thing, but I really didn't do it. But I'm getting a checkbox, so I'm able to do that. So that's what needs to be done. So what does that mean in DevSecOps program? One is cybersecurity rolling up your sleeves and actually understanding what's going on, working side by side with developers. It's real easy for me. I can write a requirement that says, thou shalt do mutual TLS between, the client and the server. Took me, 30 seconds to write that. Do you know what's involved with that? What does that mean for performance, for scalability, for supportability, all the ability things that, software has to be able to do. That's the first part, because if you make it too difficult, they're going to try to get around it, understanding it. Second is not beating people up. The one thing I love about the automotive industry, is that we learn from failures. So whether it's a space shuttle disaster, a bridge falling down or something, every failure is studied. The failure is studied. It's like, what happened? Why did it happen? What can we do to prevent that? What were the things to be able to do that? Well, in a company, it's the same mindset. If, for example, I come to your team in the API and it's like, hey, you didn't check the expiration on the token, you accepted an expired token on the API. Well, do I use that as a club to beat someone up? Or do I use it as an opportunity now to educate, to show, okay, there was a failure, how we learn from the failure? So that really is the approach to win over the developers, making it easy for them, working with them, helping them to do it. On the same side, then, that's from the bottom up for the people doing the work. It is the leadership in the company, the management. This is an investment. You're putting a pipeline in. That pipeline is going to stop things from publishing. So if I go to publish my API and it fails, and I have oh my gosh, I have this, we got to get this thing out for whatever reason why. And now all of a sudden you've become a roadblock. This process, this tool, whatever, be able to roadblock. So it's understanding both aspects of it and having that tension. Tension is good as long as it's a healthy tension between the two, meeting the conditions of the business. That's why we're at the company, at the same time, being a professional and doing it right. It's keeping that balance between the two and making it easy. So what does that mean? So, for example, one of the things implemented in the pipeline, and no pun intended, is an API to publish APIs. Okay. Publishing an API is a big deal. If you're any typical company, you got thousands and thousands of APIs. And if you don't make it easy, that's how dark APIs come about, and zombie APIs and all the other, type things out there, because you've made it so difficult or so cumbersome to publish it. It's like, I'm just going to go, fire up my own Spring Boot server, publish APIs and be done, because you've made it so difficult for me. And I need 20 people to sign off on things, whatever the case may be, to do it. So
that's such a good point. Yeah.
It's that level of understanding, living the life, working with them, again, trying to make the right thing the easiest thing to do. That's how we were able to get success doing it in a large company. But at the end of the day, you have to remember, I've done presentations, and one of my love to be able to show that is when I was at Ford, at Ford's 100th anniversary is a Ford logo. And people were at the world headquarters, basically people standing in a Ford logo, and it's taken up above. So if the people look like a Ford logo. Well, people were told many, many times, wear dark pants and the blue shirt. And if you look in the picture on the very front line, you see 4 or 5 different people wearing white pants. Even though they were told many, many times to be able to do it, they were on there. And the point is, at the end of the day, the challenge is trying to operate as a company while working as an individual. So it's maintaining the two, because at the end of the day, everyone's an individual and people are going to do what they're going to do. So it's getting them still, be able to get your individuality, what you're able to do, but operate as a company together. So that is the challenge for anyone doing DevSecOps. And if you do it right, you will get tremendous benefits out of it.
Yeah, and you have experience on both the development side and the security side. And I guess the developer buy-in is something that's really key in order to have a long-term success with DevSecOps. So, I mean, how do you encourage developers to adopt security practices? As you said, I mean, you're not going to mandate tools and practices. Is the approach to, more education and raise awareness and sort of meet developers where they are to get them on board?
Well, no, there is some mandated tools and practice if I came across it that. So it's a combination of all of them. These are non-negotiables. As a company, these are non-negotiables. These are how we operate. But it's a training, it's understanding, it's the learning from failure. As I talk about, as an engineer, a good engineer will always learn from failure. And that includes software engineers too. You learn from the failures. Every breach, every thing that's found by whatever is a failure, and understanding why it happened. So taking the path of least resistance. And that's not a developer, that's a human nature. People want to do the easiest thing. No, it's understanding and what's it like. So, because if I take you out of your context, I live in my source code editor, for example.
Mm-hmm.
When I take you out of that context, now you got to go over here to website and do these other things. I've now basically disrupted the working pattern of that developer. So things such as, having plugins, for example, in an editor are key to be able to do that, because as soon as I pivot from something else to where I spend the bulk of my time, you've already created friction for the developer. They're not going to like it. Yeah. So creating as least friction as possible is really what you're trying to do.
Yeah, and I guess on the governance side of things, then it's similar, right? You're trying to automate, or you're trying to integrate the practices we were talking about, again, around managing that open API contract, doing security testing, runtime enforcement, to integrate that into the existing automation, the existing CI/CD pipelines, to make sure that security teams can set up gateways in terms of what's the quality of the APIs that gets through, where do we block, where do we send things back to the development team for more work.
Exactly. So the thing that was so important, again, for APIs, having a single pipeline for the company, so you don't have these things that just pop out everywhere. Otherwise, it's like, how do you monitor things are, thousands of servers all over the place, and you'll never be able to keep up with it. So
not scalable.
When I see a lot of companies, I've people that on the monitoring side of APIs, they come back, a lot of companies say, we'll discover all your APIs and fix your problems, like I said, and tell you where it's doing bad things. And first I look at them like, how do you know even how it's supposed to operate? You're guessing based on it. Reverse engineering is not be able to do it. Is it supposed to operate that way and whatnot? I prefer, as an engineer, it's like, no, I am stating how it's going to operate, and we're not guessing how it operates. So it's a complete mindset change to be able to do that, where you say up front, we seriously take that this is a business capability. Remote starting a vehicle is a key business capability for an automotive company. So having that process robust, understood, documented, whatever the case may be, is a critical asset for the company. You have to think of it like that.
Yeah, there's always people offering silver bullets in the industry in terms of, you push a button and we'll solve all your problems, but there's no getting around, rolling up your sleeves, doing proper engineering work, setting out the requirements, creating your contract, doing your testing, making sure things are done right. Just in terms then of the security involvement of security in development, I've just recently seen some research from Gartner on the role of the software engineer in API security, and they identified that 60% of teams, so that's a majority of teams, securing APIs is the responsibility of the software engineers. So I guess the obvious implication then is that the security team needs to have input into the development engineers, to let them know what it is they're supposed to secure and what's expected of them. So you still need to foster that collaboration as well between security and development.
Absolutely. All companies have policies. Me writing a policies, I can say, thou shalt use a token to protect your API. Well, what does that actually mean in practice? I can make any token that I want. Well, okay, I have a token, but are you checking expiration? Are you checking the claims and the scopes? Are you checking? all the things that go along into, using token-based authorization, for example. It's great that you've used a token, but what happens when you see I'm in production and I see a pre-production token coming in? What to do? So you start going along like that. So we can say a policy is very simple. Thou shalt use a token. The reality is when you get into it, you find out, well, what does that mean to me as a developer? What are the expectations now of me using a token to protect an API? What am I required to do? What are the checks I need to make or the balances? What are the failure modes? The lessons learned from the past, where other companies or whatever breaches, whatever people out there to do that. So there's a lot, on both sides. There's the best practices, there's company policies, there's previous failures. All those things ultimately come into play of here's what using a token on an API means, for that one simple example.
Yeah. So as you say, it's about raising awareness of what's needed and then providing the tools, the environments, the practices to get developers on board with those security requirements. So Darren, what do you see as some of the exciting new trends ahead in the automotive industry?
Probably the biggest change right now is the whole electrification. In my case, once in a lifetime disruption event. We've had vehicles for years, and we've had gasoline and diesel vehicles and petrol vehicles, and again, it's been very incremental. They've gotten better. We've had more to it. Electrification changes everything, meaning that all of a sudden now the use cases are different. Don't get me wrong; it's still a vehicle. It's going to get you to point A to B. It will get you there safely, hopefully comfortably, reliably, but the parameters are different. What's important is different to the owners, to the drivers, to maintaining and whatnot. So, and I'll give you a good example of this where it makes sense. Public charging stations. You go to gasoline, to a fueling station today, you put in there, done. You don't think much about it. Well, you go to a public charging station. And one of the things people wanted, rightly so, is this concept called plug and charge. So literally, you go in, you take your vehicle, you plug it in, magically it starts charging. At one time, I said the industry did a study doing a drive across the United States. And in order for a person to basically charge a vehicle, they had to have 7 different accounts with 7 different charging operators and different profiles and whatnot. The customer experience was horrible, and it's not something people wanted. So the industry decided to come up, we're going to create this thing called plug and charge, where the vehicle, there's a relationship. The vehicle can identify itself to a public charging network, and it can then basically reference your account. So think of it kind of like the ATM system. If you've gone to the bank, I go to another bank, but I put my card in, it says, oh, okay, I know you're at this bank, I will get able to money like that. It's kind of like the equivalent of an ATM system.
Right.
Think about all the APIs now involved in that. The vehicle has to authenticate itself. Okay, it has to be able to exchange data to be able to do that. It has to be able to allow electricity to flow and not to flow. It has to, all those things have to be done. At the end of the day, it's all APIs that are doing it, making those things happen to go back and forth. It's that central nervous system of all the messages flowing back and forth. So the things that people expect now in a modern vehicle, electric as an example, they're all enabled by software, electronics, and APIs fundamentally from its core.
That's such an eye-opener. So Darren, look, we've covered a lot of topics today. We've gone through removing vulnerabilities with secure design. We've talked about the open API contract as a single source of truth, using the contract to drive quality and security across API development, testing, runtime. You talked about applying automation to do all of this at scale and with governance, and then fostering that collaboration and the buy-in from the development and security teams. So I think we've covered a lot. I hope it's been interesting and useful for anybody listening in. I really appreciate your time and sharing your expertise and your insights with us.
No, happy to get back to the communities. I got this white hair through a lot of these things.
Thanks a lot, Darren.
All right, thank you.
Thanks, guys. So now we're going to go over to a Q&A session, and we've got some questions live for Darren. One of the things that jumped out at me was the aspect of making security easy, making the right thing to do easy to do. So just curious, in your experience, if there was anything specific about the 42 Crunch products that enabled this for you in your role.
Yeah, a couple things. So at the end of the day, a pipeline is all about integration. So the fact that the 42 Crunch product set literally has APIs that I can plug into to do things, made it very beneficial. You know, the idea of the plugins from the IDE, I think, is really important too, because when you change the context, you know, I'm a developer, I'm working on code. I can stay in my environment and interact with it as opposed to now going over here to a web page. So those types of things, those little things, they may not sound like much,
Yeah.
but at the end of the day, you have to pull it all together to make it seamless. And seamless requires some integration. So the fact that we were able to integrate in through APIs to automate it really helped a lot.
Very good. There's another question here about the concept of the open API contract as being the single source of truth. So the question is, how does that work for the firewall when the APIs are in production?
An open API contract is a design intent. There where I state as a developer, this is how I intend to operate. So I give it to a consumer that says, call me. However, like in any contract, sometimes developers don't document everything. Even if you're intentional, sometimes things don't happen. So when I'm in a firewall now and data is coming in, and it's different now from when the contract states. So for example, say like there's an undocumented parameter that comes in that whatever mode equals admin. And depending on how your firewall is set up, do I block that? If it's an undocumented parameter, do I alert on it? Do I log on it? How do you want to behave when you see something that comes up that's out of the, you know, that's not in the design? So every company has to decide how they want to do that. You may want to block. That's the easiest thing to do, but that could be disruptive to the business. So depending on the nature of it, those are the things you have to look at, because at the end of the day, that's a defect. It's either a defect in the implementation, a defect in the design documentation, or both, you know, depending on the nature of it. So with that continuous improvement mindset, you got to think anything coming in, raising an alert in the firewall where it differs from the contract is a defect. And as a company, you have to decide what do I do now when I know that these defects are in production?
Okay. And then another question is, you mentioned about having a single API to deploy APIs, but the question is, how did you ensure the quality of the API was maintained when changes were made to the APIs in production? So it's kind of a segue from the previous.
Okay, so like I said, publishing an API is a big event. So in order to publish, there's checks that are made in the pipeline. So when you submit that, okay, I have this API, here's my Swagger, I want to publish it, what's necessary to publish? So do you use static analysis and binary analysis? So do you have a clean static analysis type on the source code that says, yep, there were no high issues or anything else in the actual source code of the API? That's either yes or no, depending on what your policy is. If your policy is you will launch an API that has no high, medium items found in static analysis, you check that so that you have an integration with the static analysis, you know, code system. You look for CVEs. So if you're using third-party libraries or whatnot, and I'm using a version of OpenSSL, and the version of OpenSSL in my bill of materials has a CVE. Well, when I launched it last week, it didn't, but this week a new CVE was found. So that's another source of things that you look for. So any of the third-party libraries or things you use, are there public documented, you know, vulnerabilities that are now live against that particular framework? Again, that's another blocking thing. The 42 Crunch is another item. Do you have basically a clean conformance scan where there were no defects, you know, all the defects were addressed? Do we have a minimum, what is your minimum security audit score? Meaning, do you have a well-defined contract to start with? So setting minimal levels in the pipeline that says, okay, I've achieved this level of definedness, on the security score in 42 Crunch, and I have no conform and scan defects. So those are examples of things that get checked. And if you don't pass those checks, basically the pipeline is going to say failed and not be able to publish it, your API. So that's a lot of steps. That's why I said when you publish it, the start of that whole process is an open API document that says, I want to publish this open API document. Obviously, in the corresponding code, it kicks off this whole pipeline where all these automated checks are made.
Okay, excellent. Here's another one. So you spoke about as consumed and anticipating unpredictable behavior, but how can you think of every possible scenario of the API being used in a way that was not expected?
Yeah, so use it in a way not being as expected. So it's a couple things. One is like I mentioned is, and it happens even with the best of intentions. You find undocumented parameters. Okay, where you compare the contract says I'm going to accept the values 1, 2, and 3 on this variable coming in, and you get a 4, and it returns a 200 saying it was successful. Okay, again, so that tells me it's one of two things. The implementation was wrong. Okay, it's not checking, or 4 is actually a valid item that means something to it. No, so that's some of the most obvious ones to be able to do that. But the other unanticipated is you find out it's like, I designed this API for, it's going to be called periodically, whatever, maybe 5 times, 5 times a day or 200 times a day, and all of a sudden you see it's being called 20,000 times a day, or someone wrote, someone wrote a script that calls this API, every 5 minutes, and it's basically polling it. So you get to look at usage patterns that may be outside of the design constraint. Because when you look at that API, what were the constraints? Everyone makes this is how I believe people are going to use this API and consume it. So it actually validates that are people consuming it in a manner that it was designed or in a different way. And a lot of those end up resulting in refactoring the API because there's actually use cases that the people who designed it didn't anticipate or using in a way that mattered. Again, similar to like in a truck, or our car, where we find out people, hey, one of the things like, people take their trucks to the tailgate, and if you look at a lot of the modern vehicles now, in the bed and all, there's 12 volts, so people can plug in generators and other things like that. Well, that's basically, you find out how people are using a vehicle in a manner that, oh, okay, yes, I can see how they're doing that type of stuff. So it's the same kind of mindset, is understanding who your customers are, how they use your product, and sometimes in ways that you haven't anticipated.
Okay, very good, very good. I'm just going to flick through 1 or 2 more slides that just kind of cover up on some of the information that was shared earlier. So in the bottom right-hand corner there's the white paper that has been co-authored with Darren, and that's available from the 42 Crunch website. We will be sharing a link to that as well, with a copy of the presentation today in emails being sent out to you shortly. If you do want to check out some of the 42 Crunch tooling and you haven't had the chance yet, there is a freemium version available from our website as well. So, you can try it out for free there. And of course, the APIsecurity.io newsletter, which is a very worthwhile read. It comes out every fortnight, bi-weekly, and it's reviewing all the kind of breaches and tips and tricks on how to prevent those breaches occurring, and it's documenting everything across the industry, and it's been going for 5 or 6 years now, and Anthony is the curator of that. So again, I'd just like to thank you, Darren, for your time today and all the work that you do in the industry. I think you're probably one of the most well-known faces at this stage, so we're glad to be part of that journey with you. So again, thank you very much.
Thanks for having me today.
Cheers, and thanks everybody for joining. Okay, thanks for everybody. Bye-bye.